Assalamu alaikum dear students. Students, we are starting with the electrochemical series. Electrochemical series is the arrangement of the elements in order of increasing electrode potential values. So herein you are able to see that fluorine, silver, hydrogen, sodium, calcium, potassium and lithium. These all are arranged in the order of their electrode potential value. So the question arises, how do we get these particular values? So here you are able to see that hydrogen's potential is 0. So when we keep in one container about hydrogen and at the opposite we keep any material on the galvanometer, we will get the value of that other material. So this is how we get the values of all the particular elements, and we are able to see that above the hydrogen, the values are positive. Below the hydrogen, the values are negative. So now what is the application of the electrochemical series? It tells us about the oxidizing and reducing nature of the element. More the negative value, better the reducing agent. That is why lithium, which is written at the last, is the best reducing agent. More the positive value, better is the oxidizing agent. That's the reason that fluorine is the best oxidizing agent, which is located on the top of the series. So dear students, this is going to help us to go for knowing the oxidizing and the reducing nature of your particular element. Next, if we talk about, we can go for comparison also, that how do we go for comparing the different elements. Like suppose we go for having copper. Copper 2 plus is converted to copper, the electrode potential is 0.34. Silver is when converted, silver ion when converted to silver, its value is 0.804. Zinc, when it is we are gaining, so it is, see what is happening when we are comparing the copper and silver. Your copper is reducing agent and your silver is oxidizing agent. But if we compare with the zinc, your copper is oxidizing agent wherein your zinc is the reducing agent. How it comes to know? Depending on the values. When you see the values, you can come to know this. Okay, it helps us to calculate the E0 cell. How do we know the E0 cell? E0 cell is equal to E cathode minus E anode. So cathode reduction and anode oxidation. So cathode should be bigger value and anode should be the smaller value. As here the example is given over here, that is you are able to see copper you are having 0.34, wherein zinc you are having minus 0.76. So your E0 cell is 1.1 volt. Okay, copper 0.34 and your silver 0.80. So silver 0.80 is your cathode and you are having the copper with the lower value is your anode. So herein when you go for the subtraction, that is your 80 minus 0.80 minus 0.34, the value you will be getting, that is 0.46. So this is the value of your E0 cell. Okay. Another important thing about the electrochemical series, it helps us to protect the feasibility of the reaction. That is E0 cell should be, E0 cell value we are getting positive. So it is going to show us the feasibility of the reaction also. It helps us to see whether the hydrogen is liberated when the metal reacts with acid or not. Dear student, this is very important one, that it is not always that all the metals are going to liberate the acid with the hydrogen gas with the acid. So herein we are able to see that which are those which will be liberating the hydrogen gas. That is, element whose E0 is negative is able to liberate H2. जो भी E0 की वैल्यू नेगेटिव है वो हाइड्रोजन गैस लिबरेट करेगा, बट जिसका भी E0 पॉजिटिव है they will be not able to liberate the hydrogen gas. For example, E0 value is positive, it is unable to liberate hydrogen gas. Here example is given Zn plus H2SO4, that is giving you ZnSO4 plus H2. Sodium plus HCl, 2 moles of HCl is able to give you NaCl plus H2. If we talk about the copper, let me tell you dear students, zinc and sodium, the values are negative, and that is why when the values are negative, they are able to liberate the hydrogen gas. If we talk about copper and sulfuric acid, that is H2SO4, no reaction. Reason behind it, your E0 cell of the copper is positive and therefore it is not able to liberate the hydrogen gas. So I hope the concept is clear over here. Next we are going to start with very important, that is difference of the EMF on concentration, that is given by the nearst equation. So for learning the nearst equation, first of all we are writing the general equation, that is metal in the particular aqueous solution, that is raising with the power n plus 0, n plus, that is your any value, plus electrons. When you are gaining the electrons, it is going to convert it into metal. So your E cell, that is electrode potential at any concentration, is equal to E naught cell minus 2.303 RT divided by NF, that is N is the number of electron, F is Faraday's constant, log MS, that is solid, divided by the aqueous. Now suppose the particular concentration is given over here, dear students. All the values you have to substitute and you are going to get the particular equation, that is E cell is equal to E naught cell minus 0.059 divided by N log 1 by MQ. If we talk about the two electrodes, we have to take same equation, but we have to just place it at a log cathode, concentration of the anode divided by the cathode. Equilibrium constant for the nearst equation, that is given over here, and example we are showing with the zinc plus copper ion, that is equal to copper ion plus zinc. So equilibrium constant, that is the concentration of the product divided by the concentration of the reactant. Dear student, copper and zinc in the solid form, the concentration is 1. When we keep the value 1, it is going to simply have K equilibrium. It is equal to concentration of anode divided by the concentration of the cathode. At equilibrium, the forward and backward reaction is same. So that is what you know, this E cell will be 0. So when we place this 0 over here, we get E cell is equal to 0.059 divided by N log K. Now when we take log K, we can also go for changing the values over here. That is E cell into N divided by 0.059. This is a multiplication of the previous values which are already substituted. When we take the anti-log N E naught cell is equal divided by 0.059 is equal to K. Now dear student, this is very important to note down that when we go for taking the anti-log, you are going to get the particular K value. So the K value is going to let you know how the reaction's feasibility is there. Gibbs free energy, that is delta G is equal to max work done. Delta G is equal to minus NF E naught cell, that is standard reduction potential. Delta G is also equal to minus 2.303 RT log K. What is the significance? The above equation helps us to predict the feasibility of the reaction. For any reaction to be spontaneous, delta G should be negative, for which it is important that E cell should be positive. E naught cell अगर positive है तो ही आपका delta G क्या आएगा? Negative. And delta G negative हम class 11 में भी पढ़ चुके हैं. Delta G negative means your reaction is feasible. So this much for today. In our next video, we are going to start with the conductivity of the electrolytes.